Okay, I'm almost done here. What I ended up realizing is as you laid this in, remember we got the wipeout in the frames and we have our spinny point there. We have our moment arms defined. This is 0.375 down, and we knew that the ratio of here was 3 to 1. So what I'm going to do is scale. So I'm going to learn to say that I drafted that up, hitting a cancel here. I'm going to take this, and this is actually an internal reactive force, so I'm going to see if I can call that, let's see, we'll call that a reactive force. I'm going to take this, left-click spacebar, spacebar, spacebar 3 times. And so that is the internal force that's caused. If you remember what that was caused by, that was a compression. It turns out the compression of 1.125 was caused by a unit force 1 up in the D. So let me go ahead and I'm going to write that down and take a pause here. That in effect is what you're doing for every unit force. So what we have here is a unit force at D in the positive y direction equals a compression in that member of what turns out to be 1.125. Now the question becomes, is what are the forces in these two members? And we now then realize that you have two unknowns. And so you've got this force plus this force, and then those two directions get your solution. So let me go ahead and see if I can do that in real time here. Well, I'm going to put a little circle here to call this my 0. And I'm going to say, well, that force, left-click spacebar, 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 to the move, C for copy, to the end point of that, to the center, center of that. So that's one force. That's obviously pushing in. And then we're going to left-click spacebar, C for copy. We're going to add that to my end point there. We've added two forces together. And we want to go back to home along two directions. Let's just pick that direction home. Like that, left-click spacebar, C for copy. I'm going to go home to the center right there. And of course, I got to get there along the other route, which is this route there. Left-click spacebar, C for copy. Up, grab too much. Left-click spacebar, C for copy. And I need to get from there, from this point right there, and so in effect what you see is you're actually going to need to basically realize that this force is in compression, pushing back this way. I'm sorry, in tension. And this force is neutral. If you notice that one, you see how that becomes 0 there? That, in this case, this force is neutral. If, in fact, you're going to go along one direction or the other, you could try that a couple different ways, but I'm just going to do trim. Screw that. Click that one. And so we end up knowing that, in fact, that is the force of 1.2983 in this member right here that's caused by a 1 unit force up. So you can do that, and this is actually 0 at this point. And you'll see later there's probably some reality to why that occurs. This is a 0 force member in here. But let me go ahead and unveil then the next process, and that would in effect be to go ahead and get rid of our, I don't know how we get rid of wipeout, but E cross, boy, minus layer, thaw, star, on, star, and I guess I got to do this, wipeout, frames, and then on, and now all of a sudden our frame is there so we can get rid of it. Now what you do is you go through the process again, and I'm just going to do the reactions here. You do for the process for this one force in this direction. And the process looks very similar, but you're going to realize that this force going in this way is going to be reacted with an up over here, and here is why. We're going to write a sum of the moments about A. We're going to go to our comps moment about A. We're going to do a line from the end point here, perpendicular to that line of force at D. Not working for me yet. Try it again. Line from the end point there. line from the endpoint there. Got too much going on. We don't need, if you remember, we can go ahead on a regular basis and freeze out what we don't need. And in the end, we really don't even need a bunch of this other stuff. We probably don't even need that, do we? I'm going to do a line from the endpoint here. Shift right click, perpendicular to that there. And now we have what? A force 1 this way is going to be a ratio of that to that, or 42, right, to 5.25. So it's going to be less because it's farther away. And that will then get you a force here going up. I'm going to pause and finish this out. So that, when you do the calculations, is going to be 0.125 up. I'll go ahead and put that on, hopefully on the correct layer, which is a force reactive. Again, line of here. Turning on my F8, 0.125. That's what's necessary to resist this force going up this way. But if you think about it, you can't actually just be adding forces in the X and the Y. You're going to have an equal and opposite reaction down here. Line from the endpoint here, down 0.125. And reality, because your sum of the forces in the X are 0, you're going to actually have a reaction here. Line from the endpoint here, over in that direction, 1. And so basically a single force here, D in the X, causes a reaction here in the Y going up. And once again, you can go about this process much easier if you go ahead minus layer thaw geom star. So we might want to look at the spine. We might want now look at the unit effect of that one. Remember, wipe out. 1, 2, 3, 4. And now you're going to have the same basic equation. Line from the intersection of here. If you think about where that intersects, it's kind of hard to say. Circle from the intersection of these two. Kind of hard to say what this is grabbing in here, and you might want to check that as you go through. I'm going to guess that's it, and then you have force times distance equals force times distance. That's how you go about doing it. We'll look at how you do the additions underneath. Again, this general, you do it for every single unit force in the X and the Y, and you build essentially what is a reactive matrix. In all reality, because that force was out here, it caused this. It's essentially the same thing, though later on you could actually be doing it just for the particular forces and let the reactions speak for themselves. So thanks for listening. That's 30 minutes. I don't expect you to do it, but I do expect you to kind of look at this if you have issues with how to do the basic drafting and how to deal with the effects of a unit force at any given joint. Thanks for listening.